Hello geometry students, today we are going to learn about inverse trigonometric ratio. Inverse trigonometric ratio. And in order to trigonometric ratio, in order to learn that, we need to know few things here, how to represent that. So here, very first thing we are going to do inverse tangent, that's represented as tangent. If the value of the angle is, the name of the angle is x, that's written like that. Inverse tangent of x. Inverse of sine, that's written as, if the angle is x, so that's represented as this. Suppose I'm assuming there is an angle x, and inverse of cosine, I assume it's written like this, cosine, inverse of cosine like that. And solving a right triangle, that means finding all the missing sides and angles. And keep in mind here the reference is regarding the right triangle. Let's move to the next part, like how to calculate sine in inverse tangent and all these ratios. So there, if we move, we see, if suppose this is a triangle given here and I have to get inverse trigonometric ratio, for that case let's see how to do that. So in that case, if our angle A is here, that's an acute angle, so I could, if I know that this, when I find the tangent, and so if my tangent and sine and cosine values for this angle are given, so we can easily find this angle measurement. How to find it? So it's an acute angle, and then I have to find my angle measurement. So I could use three ways. So if I have to use inverse tangent, and suppose this angle we need to find, how much is that? So if our tangent A is x, that's value is given. So how to do that? You have to bring this thing here, and this A changes to, because you're finding your measurement of angle A, that becomes this, and that becomes inverse tangent x. And you can see that it is exactly the same thing as here. You can see it's not different. These two expressions are exactly same. So it's the way it is written. So let's move to next part, where we are going to see what if this x is what. So they're just doing the same expression here. X, in this case, if you're talking about this x, what is x? X is actually tangent of A is what? So we know it is SOHCAHTOA. And A is how much? I know the x here, tangent of A is, so opposite over hypotenuse, that's BC over AC, and they just plugged it in here for x. All right, so x is, so you can simply plug it in and you get this expression. Same way, if you have to find sine, inverse sine, and sine A is given, just bring it to that side, and this will change to measurement of angle A, that's inverse of sine. And you can see it's the same expression here. And y is actually what? Sine of A is y. What is sine of A here? If I have to find sine of A, sine of A is what? So opposite over hypotenuse, that's BC over AB. And you can see they just plugged it in y here, the value of y, they just plugged it in here, and there they got measurement of angle A, the same expression. So let's move to a last trigonometric inverse trigonometric ratio. That's going to be this one. All right, inverse of cosine, that's what, if your cosine of A is given z, so if you have to find the angle A, so this, how to write it, this will change into measurement of angle A equal to, and this goes that side, it becomes inverse cosine z. And you see it's the same formula here. And z was actually what? Z was cosine A. What was cosine A? Cosine A is ka, adjacent over hypotenuse. That's AC over AB. And you can see, you can just plug it in here and that is your expression. So these are the different ways you can always find the measurement of any angle. If you have been given the ratio for that angle, the trigonometric ratio for that angle, you can always find it out. So let's see why we need to learn inverse trigonometric ratio. Purpose of this is to solve the right triangle. If you are given any right triangle and you have to solve it, what does it mean? It means finding all unknown side lengths and angle measure. Whatever is missing, you just find it out. So there could be two cases. Either two side lengths are given, and B, either one side length is given and one acute angle is given. So let me show you what does it mean. If you are talking about A, one side length means two side lengths given means if I have this, let me make a proper triangle. All right, there could be three cases. So if this is my right triangle, one case, other case, and the third case. This is my third case. All right, if we have three triangles here, right triangles, and there could be two cases, two sides are given. Maybe they have given you this side, let me change the color. Yes, maybe they have given you this side or this side, both legs. They can, you can always find the third one. Maybe they have given you this side or this side, this hypotenuse, or maybe they have given you this leg or this thing. And how can you find the third side? That's your job here. One of the things you need to do for solving a right triangle is to use Pythagorean theorem. And what it is, I told you, you don't have to memorize. It's always, you have to leg square, another leg square, that's equal to hypotenuse square. So whenever you have that, just apply that and find the third missing side. Now we got the side, but what if now I don't have any angle measurement, but just I know this is 90, and you already know the inverse trigonometric ratio. You need to know how much is this, how much is this. How to do it? Just use any of your favorite trigonometric ratio. You can use any tangent or cosine or sine, so, and take the inverse, and you can, with the help of inverse tangent or with the help of inverse cosine or inverse sine, you can always find whatever you want to use. You can always find the angles. It is used to find the angle. Find the remaining two angles. So that's the case A here. I explained you. For case B, if your one side is given and then one acute angle is given, so the picture would be different. So if one side is given, so if this is triangle, so just showing you one case, if they have given you this side, this is 90, they gave you this angle, any angle would be given. So you can always use again inverse. You can always use inverse of tangent or inverse of cosine, or you can use inverse of sine to always find any of the side, either this one or this one, depending on which ratio you're using. Once you get another side, you can use Pythagorean theorem afterwards. So there could be different steps, different ways Pythagorean to find your theorem to find third side, and once you get it, then you use again, because then you can use, if you have this angle, so you need to know how much is this, so you can find third angle by find third angle. And how can you find it? To find it, you know, the acute angles are complementary, so use that logic. Acute angles are complementary, you use that and find your third angle. This way you can solve and always get your answer for any right triangle. So I hope you get it. In the next video I'm going to show you some problems how to solve a right triangle by using inverse trigonometric ratio. Till then, stay safe. Bye.